Okay, so hello everyone and welcome. My name is Nader Dabbit. I'm going to be talking about data modeling with Amplify, GraphQL, and DynamoDB. Essentially, we're going to be looking at how to create and work with different data access patterns on a DynamoDB database using GraphQL in the Amplify library. So this is going to be broken up into 4 parts. We're going to be doing an introduction to Amplify really quickly. We're going to then be looking at the GraphQL transform library and the directives that are available there. We're going to then look at how to use that library to model different data access patterns, and then we're going to jump into a demo. So Amplify is made up of 3 main pieces. We have the CLI that creates, updates, and deletes cloud services via the command line. We have client SDKs that then allow you to interact with those cloud services from your web or mobile or native project. And then we also offer a hosting service that is there for you to be able to deploy your web applications. The CLI workflow looks something like this. You initialize a project, you add features, and then you push deployments, and then you make updates, and then you run additional pushes to push those updates to your backend resources. The CLI also does a few other things, though, and one of the things we're going to be focusing on is this GraphQL transform library. But we also do stuff like GraphQL code generation, Lambda code generation for popular use cases of Lambda functions. We do local mocking and testing for not only GraphQL APIs, but also serverless functions. And then you can also create and switch between local environments, serverless environments locally. So the GraphQL transform library we're going to be diving deep into this. It's essentially a bunch of different directives that you can add directly to your GraphQL schema that add additional features using the command line and running essentially a build at the deployment time or at the mocking time. So a few of the things that you can do, you can model relationships between different types. So we're talking about one-to-many, many-to-one, and many-to-many relationships. You can add authorization rules. You can add single or multiple authorization rules. So you can do things like add private and public access. You can do stuff like set up group access and things like that. You can create DynamoDB data sources directly on your schema. We also have this AdModel directive that does a bunch of stuff like adding additional GraphQL schema around a base type for operations like mutations, queries, and subscriptions and stuff like that. You can also model different data access patterns against DynamoDB, and under the hood, we're kind of using GSIs and sort keys, global secondary indexes. And that's kind of what we're going to be diving into a lot today. You can also set up a Lambda function or HTTP resolver, but those are 2 separate types of resolvers that kind of allow you to use AppSync as a GraphQL API gateway, and then you can port in other microservices. We also have support for Elasticsearch. But the 4 directives we're going to be focusing on today are going to be these 4 on the left. So AtModel, AtAuth, AtConnection, and AtKey. So we're going to walk through each of those really quickly. So AtModel is kind of the core directive that does quite a bit. So using AtModel, you can say, I want to have a to-do app, but all I want to do is provide a to-do type. We're going to use AtModel to make a few different assumptions to kind of get you started. First of all, we're going to create all of the different operations that you're going to need to create, read, update, delete to-dos. So we're going to create that schema for you. We're also going to create subscription definitions for onCreate, onUpdate, and onDelete. So we'll have all of that schema created as well as input types. We're going to then create a DynamoDB table for the to-do. So we're going to create like a to-do table. And then finally, we need to map those operations to the DynamoDB table. So we're going to create all of the resolvers that map between all of those operations to your table. So just running this one model, running the CLI command, we can deploy all of this infrastructure, or we can test it out locally. And then you can take those resolvers that we create and add your own business logic to kind of define additional functionality that you want, or you can create custom resolvers for additional operations that you'd like to do. We also have the @connection, and this is what allows you to define relationships between types. So a common example would be a one-to-many relationship. So for instance, we have a user that has many to-dos and a to-do that belongs to a user. To set this up, all you would need to do is add the @connection to the array that you would like to create the relationship between. And then we would automatically create a new field for to-do. That would be something like to-do user ID. And then when you create a to-do, you can assign that to-do to a user. And then when you run a query on the users, you can then fetch that child data, which would be that to-dos array for that user. So there's a bunch of stuff you can do with that connection. We're going to dive a little deeper into that later. AtAuth is what allows you to define these authorization rules. So say, for instance, we wanted to have a to-do that is only accessible by the user that created it, and only that user can not only read it, but update, delete it, and modify it. To do that, we would just add a new rule for owner, and this would assign some owner user ID under the hood to the table. And then when we run a query, we would only query for the user's to-dos. And they would only have access to those to-dos. But something more common is actually kind of a combination of two different rules, and we're going to look at how to do that. So something like a blog where you have a post type, and the post type has both public and private access. So anyone can read it, but only the owner that created or updated it only the owner that created it can update it. So we're going to look at that in just a moment as well. But the main thing we're going to be really diving into today is actually around the AtKey Directive. And AtKey is something that allows you to utilize DynamoDB's really powerful global secondary index pattern under the hood and provide a bunch of different data access patterns on all of the different types that are made up of your GraphQL schema, or made up in your GraphQL schema. So we're going to walk through this in pretty in-depth manner, and we're going to kind of also then show how to model a bunch of different data access patterns against a product type. But let's start off by looking at this kind of AtKey directive and go through each field. So the key directive takes three fields, or three different main fields. It takes a name, it takes a fields array, and it takes a query field. So the name is just going to be the index name that DynamoDB is going to create under the hood. Now this is not too important in this example here because we're not going to ever be referencing that index name. But you're going to see later that if you would like to model relationships between two types, you can actually reference this index name in a parent to kind of define the index that you would like to query on. But not worrying about that right now. You would not really need to worry about this. This is just kind of giving a unique name that's going to be built under the hood. The really interesting, or the really important part here is actually going to be the fields array and the first item that you pass into this fields array. This is going to allow us to add a new partition key, which is essentially a new column that we can query by for this type. So by default, when we use AdModel on a type of to-do, we're going to get two query access patterns. We're going to be able to get a to-do by ID, and then we're going to be able to list to-dos. That's just going to scan the table and give us all of the to-dos. But at that point, we probably are going to be okay for certain things. And under the hood, that list operation, again, is performing a scan. And you can then run a filter on that scan, but it's not a performant operation because what ends up happening is you run a scan with the filter. What's actually happening under the hood is that we're scanning that entire table, bringing back all of those items, and then filtering those out after they've already come back. What we would like to do is to perform more efficient operations for these types of queries is actually a DynamoDB query. And we can set up really powerful queries using a combination of the AtKey directive with this partition key and then in a moment the sort key. So what we're going to do here is we're going to say we want to now query on the category property. So we're creating association. When we say we want to have an AtKey with a field of category as the first item in this array, we're able to now query on this new field. And then we can say we want to get all of the to-dos of a category of this type or that type. And then we want to define the actual GraphQL operation that's going to be generated in our GraphQL schema. That's going to be this query field. So using this, we're going to now have a new GraphQL query. So we're going to have three queries now in this to-do type. We're going to have a get item by ID. We're going to have a list items. And then we're going to have a to-dos by category, which we can then use something like this. Well, we're going to say we want to look at this table and we want to be able to get the items that have a certain category and we want to perform that query. So now we're going to have this new index that's created, or this new query operation that we can call against the category row. So we can now call a query using something like this. We can say we want to get to-dos by category, and as you see, that's the same GraphQL query name that we provided in our AtKey directive. We want to get to-dos by category, and we want the category to equal shopping. This is going to perform a very efficient query operation, and we're only going to select the items that we want to get from our table, and we're not going to have to then filter because all of those items are going to already be coming back to us directly in that operation. So we're going to say we only want the category of shopping, and we're going to get that selection set. Now this is this is powerful, but what's actually more powerful is when we're able to use a combination of this partition key along with the sort key. So let's take a look at that. This is the same to-do type, and we've added one new field. We've added the priority field. We've also added two fields to that fields array in the AtKey. So when we see that we have the AtKey of name, category index, but we now have two fields. We have the category field as the first item, and then the priority field as the second item. And as you see, those actually still map to two different fields in our actual GraphQL type. But what we're doing here now is we're saying, again, like in the last example, the first field that we're passing into this array, that's going to be the partition key. That's going to be the column that we want to query on. But we're now having a second option of a sort key. And this sort key provides us with a bunch of different operations that we can now run against this new column. We're going to now be able to do stuff like equal to, less than, greater than, between, and begins with. So we can do these comparison operators on the data that's coming back. So let's take another look at this table. We have a partition key of category. So we're now saying we're going to be able to now query to-dos by category. So we can now just say, okay, we want to get all of the to-dos that equal shopping. That operation still works just like the last one that we looked at. But we now have the option of passing in also some fields to this sort key. So we can now say we want to get all of the to-dos with a category of shopping, and we want to specify the priority maybe of equal to 3, or maybe between 0 and 4, or whatever. Or maybe we want to say we want to get all of the to-dos with a priority greater than 1. So we can do all of those operations now, and all of this is done with this one key that we've just added. So a query that we might run now would look something like this. We want to get to-dos by category of shopping, and then we only want to get the priority between 1 and 3. This will give us just the first two items out of this database. And again, what we're doing is we're using these operations. So we can use equal to, less than or equal to, less than, greater than or equal to, greater than, between, or begins with. And depending on the type that you're working with, begins with, I believe, only works with the string. So begins with is something you might use for something like searching or something like that. So with that in mind, let's take a look at a more robust example. We have this product type here, and we have a product that has a name, a price, an inventory, a category, and a created at. What we want to do is we want to model 11 different data access patterns against this product type. So some of those patterns look something like this. We want to get a product by ID. We want to list all of the products. So those two are kind of given to us by default by AdModel. Now we want to add 9 additional access patterns. We want to list products in an inventory range. We want to list products in a price range. We want to search products by name. We want to list products by category. We want to search products by category. We want to list products by category in order by name. Search products by category and name. List products by category within an inventory range, and then list products by category within a price range. So that's a lot to kind of take in. But let's look at this comparison operators again, and we're going to look at the schema that we're going to work with. So what we've done, we've added a bunch of keys, and using the query fields, you can kind of get a good idea of some of the operations that we're going to be working with. We're going to be doing, be naming these query fields the things that they sound like. So products by category and inventory. Then if you look at the relationship between the actual fields, the first field is the category, and then the second is the inventory. The last one, category and price, the first field is the category. So we're going to be able to query by category, but we have the option to also query by price. So let's now go ahead and take a look at a demo. So I'm going to go ahead and open up my app that I have here. We're going to go ahead and look at this schema. So this is the main thing we're looking at. So we have all of these different fields here. We have the product field. We have we have the product type. We have the different queries that we have set up there and all of that stuff. So we're kind of ready to go. This has already been deployed. What we're going to do now is open this up in the Amplify console. And then we're going to go to the actual AppSync dashboard and test this out. So I'm going to go to API. I'm going to go to View and App Sync. And we're going to go to the schema. Just take a quick look at this. Oh, there we go. I'm trying to zoom out a little bit. Try to find the product type. So we have that product type. And then if we go to our mutations, we have create product, update, and delete product. And if we go to our queries, though, we now have all of these different operations. So we have get product and list product, but we also have all of these different operations that we defined in our schema. So products by inventory amount, products by price, so on and so forth. So let's test these out. So I'm going to go into the queries editor, and we're going to start using these queries. So before we create any queries, let's go ahead and create a couple of mutations. So I'm going to go ahead and create a product. And we're going to return the ID, the name, the inventory, the created at, the price. We'll just try to return everything, I guess, and then the base type. So to create an item, we're going to go ahead and need to provide some of these fields. So for the name, I'll call these Yeezys. For the price, I'll say 1,000. For the inventory, we'll give this maybe 100. And then for the base type, we're going to provide a base type of product. Now, we're going to be using this idea of a base type across all of the items in our database. And this is kind of a really common thing that you see done in DynamoDB. This gives you the option to have this base type as a new partition key that you can then add additional sort keys on. But it also allows you to kind of have some way to query by some base type. Now, this is especially true in single table design, but with AppSync, we're using multi-table design, but it still rings true because we still can use this base type as a partition key. So we have the name, the price, the inventory, the category. We don't have the category, so let's get the category. So the category is going to be something like shoes. Okay, so we'll go ahead and create that. We'll also create another couple of pair of shoes. I don't know what LeBron's shoes are called, but something like that probably. And then we'll also create a couple of like shirts. So we'll create like a polo shirt. And this is going to be in the category of shirts. And then I'll create a t-shirt. All right, so we've created a few different products. So if we go ahead and do a query of list products, we have a bunch of different fields. We'll go ahead and try to return all of these, and then maybe the base type. So we list products. We see that we have all of our products coming back. So now let's start doing some selection sets on these products by using these new queries. So I guess I'll go ahead and copy this, and let's go ahead and look at the different queries that we'll try to use. Let's try to first look at maybe getting products by inventory amount. I'll call this a custom query, because that way we can reuse this name. And then we'll call this products by inventory amount. And here we're going to pass in the base type of product, and then the inventory. And then we can set the operator there, And then from here, we're going to say we want to get the items. So for the inventory, we might say something like less than 500. And now we see that we have the inventory of 100 and the inventory of 200 and the inventory of 400. We could also just say we want to get the base type of products, which isn't really interesting because that's going to pretty much bring back everything. But let's say we wanted to kind of go between. Let's say we want to say between 100 and 400. We can also do that. We see that we have inventory of 100, inventory of 200, inventory of 400. We could say maybe 200 and let's say maybe like 500 and 1,000. We also get that. So yeah, there we are. We're doing some more detailed queries now. So let's now do products by price. And now for the second argument, we're going to be asking for the price, and we can say equals. It's going to be hard to do equals. Let's say greater than 500. We want to only get like these expensive items or something like that. And then we can bump this down to 300. We see that we have the price of 500, the price of 1,000. We might say between 100 and 200. We only have one item there. So we're getting now that selection set of products by price. Let's do product search by name. That's pretty interesting. We're going to now say for the name, we can now say stuff like begins with, and now we can say why. We can say begins with J. So we get Jordan's back. We can say begins with T. Let's see what else we have. So we have black t-shirts, Jordans, LeBron, Polo. So these are all different letters. So yeah, so that's kind of what's going on with the product search by name. Product search by category is also pretty good, because now we can say we want to only get the category of shoes. Now we're getting only shoes. But we could also say we want to get categories that begin with S, and that way we could maybe have like a search on our client that brings back things that start with S, and therefore we're getting both shirts and shoes back. And if we say SHO, then we're going to now only get shoes back, and if we do SHI, of course, we should only get shirts back. Let's go even further, and let's do products by category and inventory. So we're going to say we want the category to be maybe shoes, and the inventory to be between 0 and 100. We want to kind of find the things that we don't have a lot of inventory on. And then maybe we want to find the things that were like overstocked. So we might say greater than or equal to. Yeah, let's do greater than or equal to 1,000. Let's do greater than or equal to 900. We don't have anything there. Let's go back to 500. Get down to 100. So we have inventory of 100. We have inventory of 200. Inventory of 400. So we could say greater than or equal to 400 just to get that one item. And then if we said shirts, we should have some inventory of 1,000 to query against. So that's kind of the main idea, though, is that you're using these different GSIs to do all this stuff. So let's take a look at our database real quick. And it's this product table here. And if we look at the items, you'll see that we have all of the items that we've created. And if we look at our indexes though, here you'll see all of these different GSIs, global secondary indexes, products, and they're given the same name that we kind of created. So product category index, products by category index, and so on and so forth. I think I kind of had, if you look at my schema, you'll see that these are the names that I use here, but I think in my slides I kind of made these smaller and I did something like that to kind of just make less text on the screen. But this is what you end up with under the hood. And you have the name of the index, which doesn't really matter, but the partition key is going to map directly to the category, or I'm sorry, to the field that you have in your actual DB. So we have the index of partition key category, and then we should have the corresponding category row here. We have the sort key of name, created, inventory, price, all these different ones. These are also going to map over to a row in our database. So all of those are going to be kind of like mapped there. So now let's go back to the slides and continue on looking at some other stuff. So what are some other common scenarios that you might run into with Amplify that you want to kind of take advantage of or understand, I guess? One of the main ones is multiple authorization types. So we want to have a post type, something like Medium, a blog or something like that, or even WordPress, where we give owner privileges to the person that creates the item, but the only person that can read it is someone who is, or anyone can read it actually, but the only operation we're going to give to a public read, or to a public operation, is read. So owners can create, update, delete, anyone can read, and that's kind of what we want. So to do that, we set up two roles on our post type. We have the allow owner role, and this is what gives the owner privilege. And then we add another role that we call public, and we pass in the array of operations that we want public to be able to do. And in this example, we just want them to be able to read. So that's a common scenario. Another one is when we're using identity, we might want to specify the identity. So by default, we're going to set the, when we say allow owner, we're going to set the owner field as owner. But let's say we wanted to specify that owner field as something like username. We could do that by mapping the owner field string to a field that's already set on your post type. And then by default, this needs to be set as nullable, because when you create the item, you're not passing in this username. This username is being populated for you by the GraphQL resolver, and we're kind of going to be setting that in the mapping template when we're creating that item. And then you can query it back against your API. And this owner field, this username, this identity is being read off of the JWT in the resolver. And we do that by reading this property called the context.identity that's automatically passed in. Another thing that you might be interested in is combining @connection and @key. And this allows for some really powerful stuff, because then you're creating not only relationships between types, but you're defining how those relationships work. So let's take that common basic example of a one-to-many relationship. So we have a post type with many comments, and a comment belongs to a post. What we're going to do by default, if you don't define any specifics, is we're going to take this and we're going to assume that we want to have a new field, and we're just going to come up with the field name. So the field name is going to look something like this. It's going to be the parent field with the child field with then the identifier. So it's going to be something like post comments ID. So we're going to create a field on the comment called post comments ID, and then we're going to put that on the comment. So that way you create a post, then you use that post ID to create a comment, and then you use that ID as the post comments ID, and therefore you have the relationship. But that might not make a lot of sense if you want to specify what this looks like. So to do that, we can actually create that field ourselves. And to do that, we would do something like this. We would use the AtKey Directive, but the only thing we would not do is we would not add in the query field, because we're not going to be querying this directly from GraphQL. This is going to be queried from the actual query operation for the parent. So what we'll do is we'll create a key name of something like post ID index. This is going to create that GSI on the comment table. We're going to then, in the comments array, we're going to add the @connection, and we're going to specify the key name that we want to use on that child field or on that relationship field. So we're going to say The type of post has many comments. And for that connection, we want to use the key name of post ID index. We're going to then select or specify the fields that we'd like this to be queried on. So for the query of getting comments by post, we want to use the post ID that is stored in that comment table. So this is going to be mapped directly to the to the post ID in the comment. And then the ID for the post is just going to be coming in from the post itself. And we need to specify which field that is. So we're just going to say, well, it's the post ID. So it's the post ID in the parent, and it's the post ID in the relationship in the child. So a couple of pointers. I would say use local mocking in testing when playing around with these different data access patterns, and that way you can kind of make sure you get things right. And I'm going to do a quick demo of local mocking. When changing the index structures via the Amplify CLI, when you if you change a GSI structure, you're going to get some failure when you try to push it up as of today. And we're working on that because essentially what you need to do is remove the index completely and then add it back. And by default, the way the CLI works today is that it will just fail. But what we're working on is we want to be able to detect that failure, and then we want to delete it and then add it back for you. So just right now, just letting you know, if you want to change an index structure, just remove it and then add it back, and everything should be fine. You can create as many GSIs, global secondary indexes, or AtKeys as you would like to at one time. So you can create like 5 or 10 or whatever. But when you start to update those, you can only update one at a time. You can also remove as many as you would like at a time. I would look deeper if you really want to become really good at this stuff. I would maybe take a look at DynamoDB and kind of look at a talk or two on how to model data with GSIs and sort keys. I would read the data access patterns section of the Amplify documentation, and then I would also say that I would use some consistent some consistent field across all items in your DB. I use some consistent type here in my slide, but I meant use some consistent field across all items in your DB. Just like in our product type, we had that base type of product. That allows you to have that base type as a partition key. So local mocking, let's kind of take a quick look at that. In the Amplify folder, we have a couple of different things. We have our backend, our current cloud backend, and we have our team provider. But what you're going to see is that we can actually do local mocking, and in this Amplify folder, we're going to now store some data about your mocking environment. So we're going to say Amplify mock, and this is going to go ahead and allow us to mock our API locally. And this is going to first introspect our GraphQL schema, make sure it's valid. It's then going to go ahead and create all of the databases and all of the global secondary indexes and all that stuff that we need locally using the CLI. So we're going to see that we now have a post table, a comment table, and a products table. We're going to then run GraphQL code generation to generate the GraphQL code locally, and then we're going to run a local mocking server at localhost. So here we have this local graphical editor running against those databases that we created, and we can now actually run locally. So we might be able to go ahead and let me go into Amplify and just copy some of these operations that I've already done. I can now just paste these here. I can go ahead and create a product. Oops, I think I need to comment some of these out for now. So we created a product. We can list products. And we can also use this custom query. So we're using all of those features, but we're just doing it locally. You can do all of the operations, so you can even do stuff around authorization. So if you wanted to switch authorization types and set a JWT, and you can even add a group, or add someone to a group and generate the token, and then the token will be passed in the request. So you can do all that stuff locally. Pretty cool stuff. That's it. So yeah, thank you for checking this out. I'm hoping to do more of these in-depth talks, and we're going to be trying to add a lot of the stuff I just talked about into our documentation in a little bit clearer manner. But if you have any questions, check me out on Twitter at Dabbit3, and feel free to ask me any questions there. Thank you.